briefly, the period of the pendulum is the time required for one complete cycle. Remember, one complete cycle is from here to here and back. When we counted 1, 2, 3, 4, 5, etc. So we were counting actually half cycles. The whole cycle is going to take twice as long as a half cycle. Now, if we figure out how much time was required for each half cycle, remember these were all 30-second counts, so that each half cycle is going to be less than a second. Since we have 49 cycles, for example, in 30 seconds, then we have more cycles than we have seconds, which means each cycle takes less than a second. And from that, you can figure out what the time for a half cycle, for a count or a half cycle would be, and you can double that and get the period, which is the time for 2 counts. Okay, one cycle is 2 counts. Period's time for just one whole cycle. And we pretty easily get the period of 1.2 seconds for length L, 0.83 for half the length, 0.61 for half that. We sketch a graph. Now, I drew this graph carefully. It still didn't work out very well. You can eyeball any flaws I might have in the graph, but I used a unit here of 1 second, subdivided that, attempted to subdivide that into equal subintervals, and clearly these are too big, and I have a strong tendency to make these intervals too big and these too small. And then I added another interval up here, and used that as a scale. Of course, I scaled the horizontal axis length as L, half L, quarter L. So I just cut this distance in half, went twice as close to the origin again. So from here, twice as close to the origin, then twice as close to the origin again. Located my points in the graph, sketched what I thought was a pretty good curve, picked a fairly short length to double, and then doubled that, and drew my projection lines. Drew my green arrows, and eyeballing this, it looks like the Y factor is good 1.5. Probably closer to 1.6 than it is to 1.4. So that's probably a little over 1.5. Concluding then that since the Y factor is about 1.5, that we have the model Y equals A times X to the P. So if Y equals A X to the P, it follows then the 2 to the P is 1.5. Now that's for this period versus length model. Solving by trial and error or using logarithms. If you know logarithms, use them. Trial and error is okay, doesn't take long. I believe when P is 0.58 to 2 significant figures, that's the closest value of P that gives us 2 to the P equals 1.5, so that our model is period equals A times length to the 0.58 power. Again, wouldn't be a bad exercise for you to draw that graph and see what you get, and see if you get something a little better. And I'm thinking a better graph probably comes out with a factor closer to 1.4, which gives you P close to 0.5.